Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIBS Home School. This is Emdadul, Assistant Teacher of Mathematics, National Ideal Universal School, Haque. Dear students, today I am going to conduct a higher math class of class 9. Dear students, today's topic is Chapter 3, Theorem 12. This theorem I will solve in our today's class. Dear students, Theorem 12 is Ptolemy's theorem. Theorem 12 is Ptolemy's theorem. Means the mathematician Ptolemy discovered the theorem or proved the theorem, given the statement and proved the theorem. According to his name, the name of the theorem is Ptolemy's theorem. So, see the Theorem 12. At first, we need to know what is the statement of that theorem. Dear students, I am writing the statement at first. Now see here, Ch-3, Theorem 12. Theorem 12. The name of the theorem is Ptolemy's theorem. Ptolemy's theorem. This theorem I will solve in our today's class. Now, what is the theorem? At first, we have to know that statement. Or we can write the theorem directly here without writing the statement. We can write in any cyclic quadrilateral, in any cyclic quadrilateral, the area of the rectangle, is contained by the two diagonals is equal to the sum of the area of the two rectangles, contained by the two pairs of opposite sides. This is the statement of the theorem. This theorem is given by Ptolemy. According to his name, the theorem is known as Ptolemy's theorem. Okay, dear students, so if you read the statement, you will understand what is the question here. And this we need to prove. As we need to prove this, we can write here. This is our general enunciation, and now I will solve this theorem. To solve this theorem, at first we have to write special nomination. What will be our special nomination? Dear students, it means that we need to write the statement in special nomination, drawing a figure using the symbol. Okay, dear students, so see now, special nomination. So at first I will draw a figure here. As here this is written cyclic quadrilateral. So at first we have to draw a circle, and we have to draw a quadrilateral. We have to draw a quadrilateral suppose A, B, C, D is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. Cyclic quadrilateral means the quadrilateral will be inscribed in the circle. So, A, B, C, D is a cyclic quadrilateral. It is required to prove that the rectangle, area of the rectangle contained by the two diagonals, here AC and BD be two diagonals, is equal to the sum of the area of the rectangles, area of the two rectangles contained by the two pairs of opposite sides. It means that here AB is a side and its opposite side is CD. So, the rectangle contained by AB and CD and the rectangle contained by two opposite pair BC and AD. So, if we take the sum of these two rectangles, that will be equal to the rectangle contained by the two diagonals AD and BD. So, we can write here, suppose A, B, C, D be a cyclic quadrilateral. Cyclic quadrilateral. Whose two pairs of opposite sides are, here first pair we can consider AB, CD. So, we can write here AB, CD, and another pair we can consider here, that pair will be equal to BC, AD. BC, AD. Now, AC and BD be two diagonals and AC, BD be two diagonals. It is required to prove that it is required to prove that the rectangle contained by the two diagonals, it means AC and BD, it means product of AC and BD, it means that AC into BD, that is equal to the sum of the area of the two rectangles, that is contained by AB and CD. One is AB and CD, as these two sides are opposite, and another rectangle will be BC into AD, as this is also another pair of opposite side. This we need to prove. We can write according to the statement. Okay, dear students. So, prove this. We can write now proof. Now, I will prove this. AC into BD is equal to AB into CD plus BC into AD. So, to prove this, at first we can consider angle BAC, means this angle is less than angle CAD or DAC. We can consider. So we can write, assuming angle BAC is smaller than angle CAD, assuming angle BAC is smaller than angle CAD. Draw angle DAP. Draw angle DAP. Draw angle DAP at the point A with the side AD. Draw angle DAP at point A with the side AD. Okay. So that AP intersect BD. AP intersect BD at P. AP intersect BD at P. So now we can say, according to our construction, angle BAC is equal to angle DAP. According to our construction, we can say angle BAC is equal to angle DAP. This BAC means this angle and DAP means this angle. According to the construction, these two angles are equal. Now, if we add angle CAP with both angle BAC and DAP, then the new two angles will be also equal. So we can write now, so angle BAC plus angle CAP is equal to angle DAP plus angle CAP. So if we add these two angles, angle BAC and angle CAP, then we will get the total angle BAP. Total angle BAP. So we can write this here. Therefore, angle, or we can write or, angle BAP is equal to, now if we add this portion with this angle, then this will be angle DAC or CAD. We can write CAD. These two angles are equal. We can give the side note here, adding angle CAP with both sides. Okay, dear students, so now we know these two angles are equal. Okay, dear students, now listen, we can compare two triangles. At first we will compare triangle ABP and triangle ACD. At first we will compare these two triangles. So we can write here now, in triangle ABP. Now we will consider triangle ABP and triangle CAD, CAD or ACD, CAD or ACD. It means this triangle CAD or ACD. We can write anyone. If you want, you can write ACD in your book. This is written ACD. We can compare these two triangles ABP and ACD. If we compare these two triangles, we will get here angle. At first we have proved BAP equal to angle CAD. We have proved this before, and we can say angle as triangle is BAP or ABP. We can say here angle ABP. ABP is equal to angle, we can say here this angle ACD. ACD. How can we say these two angles are equal? These two angles are equal as the angle lie on the same segment. We can write here, we can write the side note, angles on the same segment of the circle. So we can write here angles on the same segment of the circle. Same segment of the circle. Here the same segment is AD. AD is the same segment. So you know that the angle lie on the same segment of a circle are equal. So these two angles are equal. Okay, dear students. So if you consider the triangle ABP and triangle ACD here, remaining angle is APB in the first triangle and remaining angle is ADC in the second triangle. So we can write here remaining angle. Remaining angle APB is equal to remaining angle ADC. Dear students, why these two remaining angles are equal? Dear students, you know that sum of the three angles of a triangle is two right angles or 180 degree. So as two angles of a triangle is equal to two angles of another triangle, so the remaining angle must be equal. So we can say the three angles of triangle ABP is equal to three angles of triangle ACD. It means that these two triangles are said to be equiangular. So these two triangles are said to be equiangular. So we can write therefore triangle ABP and triangle ACD are equiangular. Okay, dear students, as these two triangles are equiangular, you need to remember that these two triangles will be similar also. So the ratio of the similar sides of these two triangles must be equal. So we can write here ratio of the same side. So we can write here AB and AC. These two sides are AB and AC. These two sides are similar.
So we can write here AB by AC is equal to, we can take BP by CD, BP by CD, BP by CD. Now if we multiply, what will we get here? We will get here, we can write here, or AC into BP, AC into BP is equal to AB into CD, AB into CD. If we do the cross multiplication between these two fractions, we will get this term. This we can give as equation 1. Equation 1. This is equation 1. Now we can consider two triangles here. The triangles are ABC and triangle ADP. If we consider these two triangles, what will we get? What will we get? So consider these two triangles now. ABC and ABC and ADP. So we can write again, in triangle ABC and triangle ADP. ABC and ADP. We can say here angle BAC is equal to angle PAD or DAP. What we have written here, BAP or DAP? What we have written, DAP. So we can write here angle BAC means this angle is equal to angle DAP, DAP, DAP. Now we can consider another angle here. What is the another angle here? The another angle is ACB. Another angle is ACB. Now here another angle is ADP. ADP. Why these two angles are equal? This angle ADP means this angle ADB. It means that both the angles lie on the same segment AB. Angles lie on the same segment of the circle. So we can write angles on the same segment of the circle are equal. So we can say these two angles are equal. Now what is the remaining angle here? In triangle ABC, remaining angle is ABC. So we can write here, and remaining angle ABC is equal to remaining angle. What is the remaining angle here? Remaining angle is APD. APD. Remaining angle is APD. So we can write here remaining angle is APD. So we can write here again, three angles of triangle ABC is equal to three angles of triangle APD or ADP. I have written ADP. So we can say again, these two triangles are equiangular. So we can write therefore triangle ABC and triangle ADP are equiangular. As the two triangles are equiangular, so we can say the similar ratio of the similar sides must be equal. So we can consider the similar side. What are the similar sides here? Here the similar sides are, here AC is similar to if we consider AC, here this angle is here, AC is similar to AD. So we can write here AC by AD, AC by AD is equal to, now we can write BC, BC is similar to PD, BC by PD, BC by PD. These two sides are similar, AC and AD, BC and PD are similar. So we can write here, or AC into PD, AC into PD, that is equal to BC into AD, BC into AD. Now this is equation 2, this is equation 2. Now if we add equation 1 and 2, what will happen then? See, adding equation 1 and equation 2, equation 2, we get, what we will get here? We will get here AC into BP, AC into BP plus left side is AC into PD, AC into PD, that is equal to here AB into CD, AB into CD plus here right side is BC into AD, BC into AD. Okay dear students, now see, right side already matched, AB into CD, BC into AD, AB into CD, BC into AD. Right side already matched. Now we have to match the left side. To match the left side, we can take AC as common. If we take AC as common, we will get here BP plus PD. So that will be equal to AB into CD plus BC into AD, BC into AD. Therefore, we can say here BP plus PD. Now see the figure. See the figure here, BP plus PD, BP plus PD. It means that the total length is BD. So we can write here AC into BD, AC into BD, that is equal to AB into CD plus BC into AD, AB into CD plus BC into AD. It means that we have proved AC into BD. It means that the rectangle contained by the area of the rectangle contained by the two diagonals is equal to sum of the area of the squares of two pairs of opposite sides. Here it means that AB into CD plus BC into AD. Okay dear students, so I think the proof is done. The proof is done. Okay dear students, I hope you have understood how to prove this theorem. Do this as your homework. This is your homework 3. This is your homework 3. CW to HW, and learn this properly. Dear students, keep practicing at home. Abide by your parents. Stay home. Stay safe. See you again. Till then, Assalamu alaikum.